This is a problem that uses the formula that we just looked at. V sub A is equal to delta x over delta t. You can check that formula out dimensionally. Velocity is in meters per second. Displacement is in meters. Time is in seconds. So dimensionally that works out. When you rearrange, if you struggle with three-part algebra, you can always check yourself out dimensionally. Okay, let's look at number one. Now the sample problem's done for you, so you can use that as a reference. Let's do the first one together. And I'm going to here take a moment to preach the gospel of writing things down in physics. Right now you are dealing with three-part equations. They are very simple. They are very straightforward. There are not a whole lot of pieces. You will get to points where you have four variables on one axis, four variables on the other. You're rearranging and substituting to solve. If you do not write it down, you're toast. So, every time you have a physics problem, write down your variables. In this case, the potential variables we could have are average velocity, displacement, and change in time. The problem, number one, Heather and Matthew walk eastward with a speed of 0.98 meters per second. If it takes them 34 minutes to walk to the store, how far have they walked? Okay, we're given our average velocity, 0.98 meters per second. We're asked for delta x. We're asked for their displacement. The time is given as 34 minutes. What's the first thing we have to do with time? Got to convert it to seconds. So 34 minutes, 1 minute is 60 seconds. We get 2,040 seconds. Okay, so now are we ready to proceed? One more thing we got to do, rearrange. So we're solving for delta x. V sub A times delta t is equal to delta x. We just multiplied both sides by our time interval, and that yields an expression that will solve for our displacement. So now you can plug in 0.98 meters per second times 2,040 seconds is equal to our displacement. Okay, plugging that into your calculator, 1,999.2 meters is delta x. And let's also check that dimensionally. Our seconds cancel out, we're left with meters, which is the correct unit for displacement. Now, here's the tricky part. How many sig figs are we allowed to have? 2. That's going to round to 2,000 meters, isn't it? How do we write 2,000 meters with 2 sig figs? What do we need to employ? Scientific notation. So 2.0 times 10 to the third meters is delta x. And to make this answer complete, we need to include the direction they walked. So we're told that they walked eastward. This is 2.0 times 10 to the third meters to the east. So that would be our final answer. You could also say 2.0 km east. That would also be acceptable. Okay? Questions on that one?